Let's start off with the most important topic of calculus, that is integration. And let's see what exactly is integration. So, for integration, obviously, we should know the concept of derivative. And if I say derivative of a function fx is equal to g of x, and I need to find what is fx. So, if the derivative of a function is given, so I will say given g of x and find fx such that d by dx of fx is gx. So this process is known as integration. So actually you can say it's a reverse process of differentiation. Now let's see how we can find fx. So let's say we have been given derivative of a function and that is equal to 3x square. Find fx. So now what we'll do is actually do the reverse of differentiation. So we need fx. So now we will find, and what we find is that derivative of x cube is actually 3x square. So fx is equal to x cube. This process can be done with the help of a formula. So what we can do is we can say integration. So integration of 3x square dx. So we say integration with respect to x. So for with respect to x, we write dx. So integration of 3x square dx is actually x cube, right? This process is known as integration, and this symbol of integration was introduced by Leibniz. So in further classes, you'll also see the Leibniz theorem, and the dx is actually used to identify the variable, right? And this fx is known as the, you can call this the as the integral or anti-derivative, or you can call primitive. So all these names are used for integration. Now the fun part in integration is that we know that derivative of x cube is 3x square, but we also know that derivative of x cube plus 5 is also 3x square. Derivative of x cube plus 9 is also 3x square. So the question arises, if 3x square is given, out of this, which should be the answer? So that means the integration of 3x square is not unique, because depending upon this constant, right, the answers can be different, the functions can be different. So what happens is in integration, when we find integration of a function, the answer what you get, suppose the answer is fx, you add a c to it, and c is known as your constant of integration, because we don't know if the original function had a constant or not. So we'll write plus c. Now this plus c can be 0, it can be a fraction, it can be negative number, positive number. So since we don't, this c and this the entire thing, this does not have a definite value, this type of integration is known as indefinite integration, right? So what we'll do is we'll just first write down the list of formulas of integration, especially the ones which we know directly from the derivatives part. So the first formula which we used actually in the above question was integration of x raised to n dx is equal to So what we get is x raised to n plus 1 upon n plus 1 plus c. Just remember, in this case, n should not be equal to minus 1, or else the denominator will become 0. So for that, we can't use this formula. So we have a different formula for that, and we'll check that. Now we know that derivative of log x is 1 by x. So integration of 1 by x is equal to log x, or we can write ln x, or you can write log x, right? So the base is e. That's what you have to remember. Third one, you have integration of sin x dx. So derivative of cos x is minus sin x. So integration of sin x will be minus cos x plus c. Fourth one, integration of cos x. Now derivative of sin x is cos x. So integration of cos x is sin x plus c. Then you'll have integration of sec square x. Now derivative of tan x is sec square x. So integration of sec square x is tan x plus c. So similarly, we can just write the complete list. Then integration of cosec square x dx is equal to minus cot x plus c. Then you have integration of sec x tan x dx is equal to sec x plus c. Then integration of cosec x cot x dx is equal to minus cot x plus c. Now, if you remember, derivative of e raised to x was e raised to x. So that's why integration of e raised to x is e raised to x plus c. Then we have integration of a raised to x dx. This is a raised to x upon log a plus c. So these were some formulas of integration. These are specially those formulas which we find directly using derivatives. So we should know the derivative formula, and we can find the integration formula by just reversing it. So there are many more formulas in integration. So in more lectures we'll see those formulas. However, now in few lectures we'll first do the questions based on these formulas, and also remember, in each of the formula there is a plus c, which is actually constant of integration. Okay, so hope you enjoyed the video. Till next time, please take care. Bye bye.